In this video, you'll use your knowledge of indirect proof that we've been developing together with your ideas about quadrilaterals. All right, in example 1, we're asked to prove that anytime we have a parallelogram that is not a rectangle, the diagonals are not congruent. The very first thing that I'm going to do with this is rewrite it in the comfortable form given proof, because that's a little bit more comfortable for us to work with. So I'm given this parallelogram that's not a rectangle. Now, in order so that I can talk about it, write about it, express my ideas about it, I'm going to give this parallelogram a name. I'm going to call it parallelogram math. And I'm given the fact that this parallelogram is not a rectangle. And just so that I have a diagram to work with, I'm going to go ahead and sketch out my parallelogram math. And I'm being asked to prove that its diagonals are not congruent to each other. Since I've drawn this nice little diagram here, I'm going to be specific and say its diagonals are MT and HA. So I'm being asked to show that diagonal MT is not congruent to diagonal HA. The knot in the proof is my indication that I'm going to want to write this proof using the indirect format. So I'm going to go ahead and start out by assuming that diagonal MT is congruent to diagonal HA, and then identify a contradiction. So that's an assumption. What I am given to work with here is that this quadrilateral is a parallelogram. And you should be aware that anytime you have a parallelogram with congruent diagonals, that your parallelogram is always a rectangle. And that's because any parallelogram that has congruent diagonals is a rectangle. And here we're given that math is not a rectangle. So there is the contradiction. So now we've got two statements that can't possibly both be true at the same time. It must be that our assumption is false. Or in other words, that diagonal MT is not congruent to diagonal HA. And that's because we've established our contradiction. So now you've seen indirect proof, quadrilaterals, all in the same problem. All right, let's go try another one. In number 2, we're given that triangle DEG is not a right triangle. I don't really have a way to mark not a right triangle, but I am going to take my highlighter and I'm going to go highlight triangle DEG just to give me a more clear indication of exactly what it is that I'm working with here. I do know I'm probably going to want to show somewhere in my proof that triangle DEG is a right triangle and use that to establish my contradiction. The fact that we're trying to show that DEBF is not a rhombus is a clear indication to me that we're going to want to use the indirect method of proof. I'm going to go ahead and use my highlighter to highlight figure DEBF, because my first order of business here is going to be to start by assuming that DEBF is indeed a rhombus. And that is an assumption that I'm making. There are a lot of properties that I know about the rhombus. I know the rhombus is both pairs of opposite sides parallel, both pairs of opposite sides congruent. The one special property that I know with respect to the diagonals of a rhombus is that they bisect the pairs of opposite angles and that they're perpendicular. Because the diagonals of that rhombus are perpendicular, I know that the angles that are formed at point G have to be right angles. So that's where I'm going to go with my proof so that I can try to establish the fact that that red triangle is a right triangle. So because he's a rhombus, I know his diagonals, BD and EF, have to be perpendicular. I'm going to call that angle 1. And if angle 1 is a right angle, I know that the red triangle, angle D or triangle DEG, has to be a right triangle. And that's because any triangle that contains a right angle is automatically a right triangle. And herein lies my problem, my contradiction. In the givens, we're told that triangle DEG is not a right triangle. So now these two statements contradict one another. In one statement, we're saying that it is a right triangle. In the other statement, we're saying that it is not a right triangle. So the statement that led us to this contradiction must be a false statement. Or in other words, we can go ahead and conclude that quadrilateral DEBF has to be a rhombus. So that's my final statement down here. And the reason I know this is I had these two contradictory statements. As always, I thank you for the gift of your time, for investing your time in order to learn this material. Again, I want you to summarize the key ideas and important takeaways that you need to remember from this video, and then see if you can apply what you've learned in order to write a proof on that last page of your notes packet.